Welcome back to my channel. This is Sabright. We want to talk on qualitative analysis. Now, in qualitative analysis of cations, we have two key observations to be recorded, which is the color of precipitate, if there is any, and the solubility of precipitate in excess reagent. I'll be looking at calcium ion, zinc ion, aluminum ion, and lead ion, and we'll be using two reagents, aqueous sodium hydroxide and aqueous ammonia, to test the cations in both SS and in drop, in both drop and in SS. We'll be using some test tube to do that, separate test tube for the two reagents. So let us go ahead with the respective tests. Now we have when you pour sodium hydroxide in drop to solution containing calcium ion, you will notice that a white precipitate is formed when sodium hydroxide is added in drop. If you're not seeing it, you could use a white tile and so that it will appear. So the solution appears chalky because the white precipitate is suspended. Now, adding sodium hydroxide in excess, the white precipitate remains insoluble. The white precipitate remains insoluble in excess sodium hydroxide. To be certain if the precipitate has dissolved, you should hold the test tube against a bright background, that's either a white tile. If you're able to see through the test tube, it means that it is insoluble. Okay, we will now add aqueous ammonia to a solution containing calcium ion and see what happens. In drop, you find out that there is no visible reaction when aqueous ammonia is added in drop to calcium ion. Look through it, there is no precipitate, no visible reaction. Now if it's added in excess, there is still no visible reaction present, which means aqueous ammonia does not react in a solution containing calcium ion. Okay, let's go over to a solution containing zinc, a colorless solution containing zinc. Let's add few drops of sodium hydroxide and see what happens. A white precipitate is formed. A white precipitate is formed. A white precipitate is formed when sodium hydroxide is added in drop to a solution containing zinc ion. Now, adding sodium hydroxide in excess, remember to always stir continuously. If you add it in excess, the white precipitate becomes soluble in sodium hydroxide. So white precipitate dissolves in excess sodium hydroxide. The white precipitate dissolves in excess sodium hydroxide. Now let's go over to aqueous ammonia. To that solution containing zinc, let's add aqueous ammonia in drop. Aqueous ammonia in drop, when added to a zinc containing substance, a white precipitate is formed. So a white precipitate is formed in aqueous ammonia in drop. If you check it where you see a white precipitate is formed. Now when aqueous ammonia is added in excess and you shake it, the precipitate starts to dissolve when more of the reagent is added. Now if you continue adding until all the solid disappears, you should continue adding, then a white precipitate is soluble in sodium hydroxide. You find out that the white precipitate is soluble and a colorless solution is observed. A colorless solution is observed. Okay, now go to aluminium. If you add in drops sodium hydroxide to a solution containing aluminium, a white precipitate is formed. A white precipitate is formed also. Adding it in excess, adding sodium hydroxide in excess, the white precipitate dissolves. The white precipitate dissolves in excess sodium hydroxide. The white precipitate dissolves in excess sodium hydroxide. Now let's use aqueous ammonia. Adding aqueous ammonia in drop to the solution containing aluminium, a white precipitate is also formed. A white precipitate is formed. Adding aqueous ammonia in excess, you find out that you shake it, stir it, the white precipitate remains insoluble. The white precipitate is insoluble in excess aqueous ammonia. Okay, let's go to lead. To a colorless solution that contains lead, add aqueous sodium hydroxide. A white precipitate is formed when sodium hydroxide is added and drop. Now, excess of sodium hydroxide, adding excess of sodium hydroxide and stir continuously, the precipitate remains soluble. The precipitate dissolves in excess sodium hydroxide. The precipitate dissolves in excess sodium hydroxide. Okay, it dissolves, it's no longer there. Okay, let's use to a colorless solution that contains lead. Let's add aqueous ammonia in drop. Then adding aqueous ammonia in drop and stir, a white precipitate is formed. So that means that a white precipitate is formed when aqueous ammonia is added in drop to a solution containing lead. Now, adding excess of the aqueous ammonia solution, the white precipitate is insoluble. The white precipitate is insoluble. It refuses to dissolve. The white precipitate remains insoluble. Okay, let's go over to iron, iron 2 and iron 3 plus copper as well as ammonia. Okay, to a solution containing iron 2, if we add a dirty green precipitate is formed when sodium hydroxide is added. You look at it there, a dirty green precipitate is formed and drop. In excess, the precipitate remains insoluble. The precipitate remains insoluble. The precipitate remains insoluble. Now let's add aqueous ammonia to the same solution of iron 2. Okay, what happens there? A dirty green precipitate is formed when aqueous ammonia is added and drop. The dirty green precipitate remains insoluble in excess aqueous ammonia. But in drop, the dirty green precipitate appears, then in excess of it, it still remains. Now, to a pale yellow solution that contains iron 3, add aqueous sodium hydroxide and drop. Adding aqueous sodium hydroxide and drop, you will notice what happens there. A reddish brown precipitate is formed. A reddish brown precipitate is formed and drop. Now, the reddish brown precipitate remains insoluble in excess sodium hydroxide. The reddish brown precipitate remains insoluble in excess sodium hydroxide. It remains insoluble. Okay, let's get aqueous ammonia. Adding aqueous ammonia and drop to a pale yellow solution that contains iron 3. Let's see what observations will be. Okay, you've seen it. A reddish brown precipitate is formed when aqueous ammonia is added and drop. A reddish brown precipitate is formed when aqueous ammonia is added and drop. Adding excess of aqueous ammonia, the reddish brown precipitate remains insoluble. The reddish brown precipitate remains insoluble in excess aqueous ammonia. Okay, let's go over to copper. To a blue solution that contains copper, add aqueous solution of sodium hydroxide. Add aqueous sodium hydroxide. So a light blue precipitate is formed when sodium hydroxide is added and drop. A light blue precipitate is formed when aqueous sodium hydroxide is added and drop. But when sodium hydroxide is added in excess, the precipitate remains insoluble. The light blue precipitate remains insoluble. So it remains insoluble. So if you want to still be certain, remember you hold the test tube against a bright background to be certain if the precipitate is remaining or is insoluble. Okay, to a blue solution that contains copper, add aqueous ammonia in drop followed by in excess. Adding aqueous ammonia in drop, a light blue precipitate is formed when aqueous ammonia is added in drop. A light blue precipitate is formed when aqueous ammonia is added in drop. Okay, now when you add aqueous ammonia in excess, the light blue precipitate is soluble. Look at it, it dissolves. The light blue precipitate dissolves to give a dark blue solution. The light blue precipitate dissolves to give a dark blue solution. The test for ammonia is different compared to the other cation. So for ammonium, the test is different compared to the other cation. If you add sodium hydroxide, there is no visible reaction. Now, After the addition of sodium hydroxide, the mixture is heated and the gas evolved is tested with a moist red litmus paper. So the test is going to, you're going to apply heat for ammonium. Wet the red litmus paper before heating the sample. Take note, you have to wet it, touch it, make it wet before heating it. Now, after heating the solution, bring that your litmus paper close to the heat so that the gas, it will feel the gas coming out from the test tube. Do not heat the sample for a prolonged period of time. Instead, heat it in a short interval and remove from the test tube occasionally. From the test tube occasionally. This will prevent it from breaking. Okay. Now you see that the this thing, moist red litmus paper turns blue. Do you know what gas that is produced? Do you know the name of the gas that is produced? So you let me know the name of the gas that is produced. Okay, to a colorless solution that contains ammonium, add an equal volume of aqueous ammonia. No visible reaction. No visible reaction is formed when you add that. Now, no visible reaction is add in a little drop of that. No visible reaction is. Now that you have finished the video, it will be good if you create a flow chart and summarize the different types of tests and observation expected. You will notice that if we only use one reagent, for instance sodium hydroxide, there is going to be similar tests for this. Thanks for watching. Always subscribe to the channel for more. Thank you.